Now we all know what is current, what is potential difference, then what is resistance. Also you all know what is Ohm's law. So those who are watching the video for the first time, we are doing lessons on current electricity. All the previous lessons from this chapter can be seen if you look at the playlist in the channel, or you can directly go to the description box. There all the links of previous lessons are given. Now today's topic is electromotive force, that is EMF. So from the name, actually you must have heard of this name, word EMF, EMF of a cell, etc. many a times. So from the word itself we can understand, get a clue of what is actually electromotive force. So it is a force which helps the electrons to move, a motivating force which helps the electron to move, isn't it? So it is easy to remember the word electromotive force, EMF, motivating force for the electrons. So actually what is this electromotive force? How can you calculate electromotive force? All these will be done in this video. Now before that, before defining what is EMF, let us see what is actually an electric cell. So electric cell means it is a device which converts chemical energy to electrical energy. That is, we are getting electricity by means of chemical reaction. So that type of device is known as electric cell. In its simplest form, an electric cell can be shown as shown here. That is, there will be a vessel or an apparatus which contains electrolyte. Okay, electrolyte is there, so it will be in semi-liquid form or in liquid form mainly. Then you have two electrodes, cathode and anode. Positive electrode is known as anode and negative electrode is known as cathode, which is dipped inside the electrolyte, and we will get electricity from these two terminals. That is, this is the positive terminal and this is the negative terminal. So this is the simplest form of electric cell, where the electrolyte will be chemically dissociating and the ions will be moving and we'll get electricity. I'm not going to the details of the chemical reaction which is happening here. We'll do that, those detailed learning of electrolysis or how the electric cell works in some other videos. Now our concern is about electromotive force or the voltage of the cell. Okay, so simply you have to keep in mind that an electric cell will have electrolyte inside it, positive anode will be there and negative cathode will be there. Okay, now there are different types of electric cells like Voltaic cell, Lagrange cell, Daniell cell, dry cell, etc. So actually the difference in all these cells is the difference in the electrolyte which is being used, or difference in the cathode and anode which are being used. So depending upon the type of electrolyte, cathode material which is used or anode material which is used, we have different types of electric cells. Okay, I'll show the pictures of those electric cells. So here the first one which you can see is a Voltaic cell. So Voltaic cell actually provides a voltage of 1.08 volt. It is given there. I'll give the details of that later. So in Voltaic cell, see the electrolytes you can see here. Then electrode is there. Okay, then copper is dipped in copper sulfate. So there is an arrangement for the electrolyte and electrode, anode and cathode in Voltaic cell. When you look at the Lagrange cell, the setup is a little bit different. Okay, so inside the Lagrange cell also there will be electrolyte, then one positive anode and negative cathode will be there for the Lagrange cell also, and it will provide a voltage of 1.5 volt. We will get 1.5 volt from this Lagrange cell. Now another type of cell, electric cell, is Daniell cell, So there also inside the Daniell cell you have electrolyte, positive electrode and negative electrode, cathode and anode will be there, and there also we will get electricity out of that. The voltage that we get is 1.08 volt in this case. Now the most common cell that you have seen is the dry cell. So this is a very familiar cell for you people. So this is a dry cell which is having 1.5 volt, and another dry cell, this is giving 9 volt. Okay, so here inside the dry cell also we have electrolytes, positive and negative electrodes are there, from which we get the voltage. Okay, so these are the different types of cells that we see in maybe in laboratory or maybe in a daily use. Now actually our topic is electromotive force. Now let us see what is electromotive force in detail. So if you have a cell, so you know you represent the cell like this, isn't it? One positive will be there, one negative will be there. Okay, and we can connect that cell to a resistor or a device. Resistor means it can be a device, and of course there will be a key or a switch will be there. Okay, so this is the switch or the key. Now it is in open circuit. Open circuit means the current is not flowing through the circuit. This is not in contact. Okay, so that is open circuit. If we want to close the circuit, you have to close it like this. Okay, so this is a circuit. So if I am going to draw it in a cell model, so this one electrode, positive electrode will be there, negative electrode will be there, electrolyte will be inside it, and we can connect. So this is actually the cell which I have shown, this one, and we will connect it to a device. Okay, and there will be one switch or a key will be there to switch on and off the circuit. Okay, so now I told you about different types of cells, and I told that different types of cells are having different voltages. Dry cell, it is giving 9 volt, then 1.5 volt. Daniell cell, it is giving 1.8 volt and all. Okay, now let us see what is this 1.8 volt or what is this 9 volt or 1.5 volt. For that, that is actually the EMF of the cell. Now let us see what is actually EMF of the cell. So you know, whenever this electrodes, that is positive electrode and negative electrode, whenever there is a potential difference between them, the current will be able to flow through the circuit. Only if there is a potential difference, the current will flow through the circuit. Or current is able to flow only if there is a potential difference. So we can define the EMF of a cell as, suppose you are not giving any, if we are opening the circuit. Okay, let us suppose that the circuit is in open form. Open form means current is not drawing through the circuit. Okay, current is not flowing through the circuit. It is actually the open circuit. So I will draw it once more. So we have the cell here, then we have the resistance or any device, maybe a bulb, maybe any device. Okay, so this is our device, and we are giving a voltage. Positive is there, negative is there. Suppose this device is not drawing any current, is not drawing current, that is it is not using current, we are not using current from the cell, then whatever potential difference is there for this cell, we name that to be EMF. That is actually, if you are keeping a cell simply without any connection, that cell will be having a voltage or a potential difference between the positive electrode and the negative electrode. That is actually known as EMF of the cell. So whatever I have written here, that is 1.08 volt or 1.5 volt or 1.8 volt or whatever is written on the dry cell which you purchase, those are actually the EMF of the cell. Okay, so that that whatever it is written there is the potential difference between the positive and negative terminal or positive and negative electrode of the cell when they are not in use, when we are not using the cell, or when current is not drawn from the cell. Okay, now we will define EMF in detail. The potential difference between the terminals of the cell when the cell is in open circuit. Open circuit means when the cell is not used, is called electromotive force, and it is abbreviated as EMF. And it is written using like this. This is actually a Greek letter epsilon, or you can write it as a stylish E. Okay, so this is the representation of EMF. Okay, so potential difference between the terminals of the cell when the cell is in open circuit, that is when the cell is not being used, is called electromotive force. So whatever voltage or the potential difference the cell got altogether, it is known as electromotive force. Okay, now let us we know we have already defined potential or potential difference in terms of work done. I hope you remember we have already defined potential difference as work done per unit charge. So this EMF, since it is a potential difference, we can write EMF also in terms of work done. Now let us see what is actually EMF in terms of work done by a charge. In order to define EMF in terms of work done by a charge, let us suppose that we have a unit positive charge. Okay, because when we defined the potential, also it was defined in terms of work done by unit positive charge. So similarly, in order to define EMF also, we have to take unit positive charge. So suppose we have a unit positive charge, and if I am going to move unit positive charge throughout the circuit, that is I am going to make the unit positive charge to move through the external circuit. So this is the external circuit in which our device or the resistance is connected. So if I want to move the unit positive charge through the external circuit, I have to do some work, isn't it? And when it reaches the cell, the charge will have to move inside the cell, that is inside the electrolyte. So there also we have to do some work. So we can define EMF of the cell as the work done to move a unit positive charge through the external circuit, that is outside the cell. Okay, so this is outside the cell through the circuit, and also to move the charge inside the cell through the electrolyte. Okay, so you can define EMF of the cell as work done to move a unit positive charge outside the cell through the circuit, and also inside the cell through the electrolyte. So we'll define once more. The EMF of a cell is defined as work done in taking a unit positive charge around the complete circuit. So complete circuit means inside the cell as well as outside the cell. Okay, that is in the circuit, outside the cell. So that is the external circuit, or the external resistance, through the external resistance that we have connected, and in the electrolyte inside the cell. Okay, so that is EMF of the cell. So we can define EMF as work done per unit charge. So work done divided by the charge. Okay, and this work done is for two purposes, that is work done to move charge inside the cell through electrolyte. So inside the cell the charge is moving through electrolyte, and outside the cell the charge is moving. Second work is done to move the charge through the outside the cell through the external circuit, or through the circuit, okay, or through the resistance which we have connected. So that is about the EMF in terms of work done. So if W is the work done to move the charge Q0, then we can write EMF E is equal to W by Q0, where W is the work done to move the charge outside the cell as well as through the electrolyte inside the cell or through the complete circuit. So that is known as EMF of the cell in terms of work done. So we will define EMF of the cell once more. The EMF of the cell can be defined in two ways. The first one is, it is defined as the potential difference between the terminals of the cell when the cell is in open circuit. That means if we are not using a cell, whatever potential is there in that cell, we name that to be the EMF of the cell. The second way of defining the EMF is defined as the work done in taking unit positive charge around the complete circuit. So complete circuit means inside the cell as well as outside the cell. So outside the cell we have the resistors or the device which we have connected, and inside the cell we have the electrolyte. So when the charge is moving, we have to do some work throughout the circuit. So that work per unit charge also can be defined as EMF of the cell. Factors affecting EMF of a cell. So there are mainly two factors that affect the EMF of the cell. As I have shown earlier, EMF of different cells are different. That is, Lagrange cell is having different EMF compared to that of Voltaic cell. Daniell cell is having a different EMF compared to that of dry cell, etc. Isn't it? So EMF actually depends upon the nature of the cell. So actually these cells differ in their electrolyte, differ in their electrodes and all. Okay, so there are two factors which affect the EMF of the cell. So the first factor is the material of the electrode. The material of the electrode. That is, these electrode, positive electrode, anode and cathode, can be made of different material, maybe zinc, maybe copper, maybe platinum, etc. Isn't it? So different sin material will affect the EMF value also. The second factor, of course, will be the electrolyte which we are using. So different cells will be having, or different cells will be using different type of electrolyte and different types of electrodes. So these two factors are the factors that affect the value of EMF. So the material of the electrode which we use and the electrolyte which we are using for making that particular cell, these two factors will affect the EMF of the cell. Now the factors that do not affect. So there are certain factors that don't affect the EMF. Let us see those factors also. So one important factor that won't affect the EMF is the shape of the electrode. Okay, so whatever be the shape of the electrode, it can be cylindrical in shape, it can be cuboid in shape. Okay, so whatever be the shape of the electrode, the EMF won't be affected. It don't have any effect on the shape of the electrode. Then second one is the distance between the electrode. Okay, that is, electrode can be kept at any distance. Any distance means possible distance, distance between the electrode. It also won't affect the EMF. It won't affect the EMF of the cell. Then also the amount of electrolyte, whatever be the amount of electrolyte, that also won't affect the EMF of the cell. Amount of electrolyte. This also will not affect the EMF of the cell. So shape of the electrode won't affect the EMF. Distance between the electrode won't affect the EMF. Amount of electrolyte will not affect the EMF. And also the one more factor is there, the current drawn. from the cell, because EMF is actually the nature of the cell only, so it don't depend upon the external resistors which are being connected. So the current which is being drawn from the cell will also not affect the EMF of the cell. So the EMF is actually the nature of the cell, type of cell. So EMF depends only on the material of the electrode which we are using for the construction of cell, and also the nature of electrolyte which is being used for the making of that particular cell. So that those are the factors that affect EMF, and those which are not affecting the EMF value of the